Hey y'all, this is Mrs. McGrain, and I want to go ahead and do this lesson. This is Monday, November 16th, and I did not record the lesson from this morning, so I just want to make sure that we record the lesson and you're able to see what it was that we talked about Monday, the 16th. And then also for my afternoon kiddos, this is going to be what's going to be happening or what happened on Wednesday. So this is the lesson for the homecoming story. Last unit was all about stars, Unit 2 stars. This is now Unit 3 on Earth's origins. So we first started our conversation with each other this year on the origins of the universe. That was Unit 1. And we talked about how the universe began. Then we moved into Unit 2, which was all about stars. And we said, okay, what was the first large material that began to be created? And that was stars. Our very first stars were hydrogen burning stars making helium. And then when those stars processed through their life and died, we had more elements that were released in the universe. And over time, the elements that were created through the fusion that was happening in stars, and then also the death of supernovas of our high mass stars, created more of the elements that were happening in the universe. So, Unit 1 was about how the universe began. Unit 2 was then how stars were created in the universe. Unit 3 is going to be about how planets were then created around those stars, our planet being one of them. So, Unit 3 is entitled Origins of Earth, or Earth Origins. Excuse me. So, if we look at what we are doing for today, it says if you could get a brand new piece of paper out, this is going to be your new notebook paper for your daily questions. And if you are continuing to do that in online, we're not going to be, you can utilize that online format if you want to continue. I'm fine with that. But we're really going to be using today that packet that I gave out, and I also emailed it, excuse me, not emailed it, I mailed it out to everybody. So we're using this packet for Unit 3. So at the top of a new notebook piece of paper, put Unit 3, Earth's Origins. And we are going to, then it says, draw a picture of our solar system. Be sure to label the Earth and the Sun, which we did. You can see that we went ahead and we put the Sun in the middle. It's the largest object that we have in our solar system. And then we put 9 different planets in orbit around the, the Sun. And so, of course, I did not label where the Earth was, so I should do that right now. I will go ahead and pick this color, and it goes my very excellent. So this is the Earth, a nice acronym to remember what all of the planets are. Would be my very excellent mother just served us nachos. That's 8 planets. That gives us Mercury, Venus, Earth. Where's Mars? Mars would be the next one. And then we go Jupiter. So my very excellent mother just, served would be Saturn. There's Saturn with its ring. Us would be Uranus. And then nachos would be Neptune. Pluto is no longer one of our planets. It is called a dwarf planet. They no longer classify it as a full planet. All right. Although it is part of the solar system, it's not considered a planet in the solar system. So then what we did was we opened up our packet, and it said on this packet, we did a little story about homecoming because y'all couldn't have homecoming. So Mrs. McGrain brought homecoming to you. And it said, we said stars were born in nebula. But how does this happen? And we need to remind ourselves that a nebula is a giant cloud full of elements. And it is proof that stars came and went before this moment in time. So stars were born in nebula. We call them star nurseries or stellar nurseries where baby stars are born. This was last unit. But how does this happen? We're going to follow the story of students at a homecoming dance to better understand what's called the nebular theory. Below, we drew pictures and captions of the major events on the story on this side of the paper. the left side, and then on the right side we demonstrated what was actually happening in a nebula, a giant cloud of dust and gas, that matches the analogy. So it's a way to kind of teach this idea of a nebular theory. Now, when we talked about the Big Bang theory, that was how we believe our universe started. So the nebular theory is now talking about how solar systems are created, how planets are created around a star. All right. So let's talk about the homecoming dance. When you have a homecoming dance, you need to have a good homecoming dance. You have to have ingredients to build a dance. And so our ingredients for the homecoming dance are going to be our students and it's going to be our DJ. So in this particular picture, what we did was we said that all the students arrived in their finest clothes for the homecoming dance, and everybody's excited to get their groove on. But wait, the DJ is late. No. And everyone just stands around. So these are people kind of distributed evenly throughout, let's say, our cafeteria area at Liberty. There's nothing yet to start the dance to get the process going. So they're just kind of all floating around, just hanging out, really just waiting for something to begin. If we look at our nebular theory, when we talk about what we need to build a solar system, we need the ingredients. We need all of the elements that are found in this giant cloud of dust and gas. And so this is a cloud of elements called a nebula cloud. This cloud of gas and dust, also known as a nebula, is kind of just out in space. It's not really moving or doing anything. There's just lots of potential at this point. All of the elements that we find in our planet today come from this cloud of dust and gas. So what I want you to do is pause the video, draw the pictures, and then start the video again when you're ready. In the next scene for the dance, what gets the dance started is the DJ has arrived, and he starts off playing levitating feet. And so Mrs. McGrain was jamming out to that one earlier. And it's an okay song. Some people are like, oh my gosh, this song, I love it. And they run to the dance floor. And so you start getting people moving around. A bulk of the people, though, are still kind of hanging out around the end, not really getting involved yet. But the music is the starting point, the catalyst, the push, if you will, to get the dance going. If we look at our story for the nebula theory, we can see that this cloud needs some sort of push to get parts of it to start collapsing in on itself so that it can accumulate enough mass in different pockets that those can then become stars and the planets around the star. So we believe that something like a distant star exploding in a supernova would send this wave of energy floating through outer space, and it would nudge a little bit of the elements in the cloud enough to kind of start collapsing a little bit of that cloud. And then one particle would be kind of drawn closer to another particle. And since they're made of mass, they have a certain amount of gravity. And then they start to accumulate more mass, which makes more gravity, and they accumulate more mass. And so then you start to get this buildup of elements, of elements clumping together within the cloud. That again is what gets the process started, like our DJ gets the dance started. Okay, so pause again when you need. Okay, eventually the DJ plays "Take You Dancing" by Jason, and you get everybody like, "Oh my God, this is my jam!" And everybody runs to the dance floor, and everybody starts moving together, right? And so you can see the movement on the dance floor, and people start moving around, and the dance really starts going. On the nebular theory side of it, not the whole cloud, but a portion of the cloud that has gathered enough mass starts slowly rotating. And if you've ever seen a figure skater when they are spinning and they've got their arms out and then they pull their arms in, they start spinning faster. That is what's going to happen with this clump of matter, this mass, that as it becomes more concentrated, it's going to start spinning faster and faster. Once that happens, it begins to flatten out. And so we say that it begins to rotate. You get a bulge of most material on the inside, and then the edges start to flatten out a little bit. This is now called the protoplanetary disk. Protoplanetary means it's not planets yet, but the planets will form eventually in this disk of material around the center bulge. All right. Next, if we go back to our homecoming dance, finally the DJ starts playing like one of the greatest songs. And I just picked a song from Outkast called Hey Yay. But you can pick any song you want. I don't care. But everybody's dancing and the heat starts increasing in the middle of that dance. And so what we've drawn is we've drawn little heat waves. We've drawn energy waves coming out. So if you could bring a thermometer to the center of the dance floor where everybody's packed together, you've got heat, you've got lots of mass, you've got lots of friction, and so the temperature is going to increase. And if we looked at it with a thermal camera, you would see it glowing hot. That is what's happening inside the protoplanetary disk in the center. So 99.9% of all the material is in the center. That mass is eventually going to become the star. The 0.1% at the outer edges of the disk will eventually become the planets. So all of the planets that we have in our solar system, all the leftovers that were not included in the mass of the star, that is what becomes our planets, like our planet Earth. So we can see here, we drew some lines to show that it's glowing at this point because it's really hot, but it's not nuclear fusion yet. Nuclear fusion will not start. Excuse me, it's not a star yet. It's not a star until nuclear fusion happens. The moment there's enough pressure and heat and nuclear fusion clicks on, then it's a real star. Once that happens, that burst of energy is then going to kind of send the lighter elements that are remaining in this protoplanetary disk are going to be more pushed to the outside of the edge of the disk. That's going to create our lighter gas giants of planets. And then the inside is going to be where the heavier elements are closer to the star. Those are going to be our four rocky planets, Mercury, Venus, Earth, and Mars, that have been created. So heavier elements stay closer to the center star, and the lighter elements get pushed out and begin to accumulate, creating our gas giants. All right. So the dance has been going on for a while. The great song kind of ends. Some people start to move away from the center because it's getting really hot in there. So this is going to represent, in our nebular theory story, the star again is the mass in the center. Most students stay there. It's really hot. And then the outer edge of the dance, children or students are going to start to accumulate. They're going to bunch together. Maybe Angel comes out and is like, "Ooh, I'm hot. I'm going to go get a drink." And so he's out. And then Lucas sees him and says, "Hey, how you doing? I'm going to go over and hang out." And you get more mass accumulating in bunches. And then Paris comes out over here, and then Emma joins her, and then Carly joins her. And so then you get these groups that are bunching up. And through accumulation, these groups are going to end up being our planets in our story. So let's go out to the edge of the protoplanetary disk. Over here it says, meanwhile, at the edge of the protoplanetary disk, which, to remind you, is this area out here, the edge of the disk, you have bits of material that begin to accumulate. They crash into each other, and then some of it spins off and flies away, but the bulk of it stays together. And as this happens, particles then begin to attract each other, because as you have more matter in one space, more mass, increases the amount of gravity for that object, and then it attracts more and more particles. So these particles grow larger and larger over time. That's what's happening on the edge of our dance floor. So these are now called planetesimals. They're small to about, I don't know, meteor size. They have the word planet in them because eventually they will become planets. But right now, they're just the building blocks of the planets. So all of the elements that create the planets are now locked in those particles. All right, let's go down farther. As the night goes on, students get tired of dancing. The dance starts to clear out. More students clump on the edge. So the planets are getting larger and larger around the center star. If we look at our nebula theory, those planetesimals that were here begin to accumulate more and more and eventually becomes protoplanets. They're very large, but they're not spherical shaped yet. They had not been turned into a sphere like a planet yet. With more mass becomes more gravity, and gravity draws everything into the center. So it literally pulls everything to this perfect sphere because it's trying to pull every single edge of this planet into the center, which makes it this round ball shape or sphere shape. So over time, the planetesimals come together and create protoplanets, and then eventually, with enough time, it creates something large called a planet. The process of this happening is called accretion. Accretion is kind of like if you have a snowball and you throw it against a brick wall. Part of the snowball sticks to the brick wall, and you've just added mass to the brick wall. Some of the snow falls away, but a part of the snow sticks. Over time, if you kept throwing snowballs at that wall, you would be building more and more mass of the wall through what's called accretion. That's what's happening in order to make the planets. And this is a millions of years process in order to get planets that shape to the size of our planet and Jupiter and Mercury and all of the other planets that we put together in our first picture. So the planets are created, and remember, our solar system is 4.6 billion years. So we had lots of different planets that were in different orbital paths. Some of them crossed the same orbital paths, and those planets would have smashed into each other over the last 4.6 billion years, so that what we're left with now are just the planets that aren't crossing path with each other. Everything else has either been smashed into smithereens or been hit and knocked out of our solar system within the last 4 billion years, so that we have this nice organized solar system that you see today. But it's been a long process in order to get to the point where we are now. So that is the latest, most accepted theory for how solar systems are created, how the center star is created, and then the planets are created around that solar star, center star. But there are other ideas for possible ways planets could form. And I want you to go ahead, if you're interested, to look at this podcast that I have linked here, and it describes these other ways. Keep in mind that the science, the best science we have now, confirms what I've just walked through in the nebular theory. But there are other ideas out there, and if you are interested in learning about those ideas, you can do so at this tiny URL. Tomorrow, if you could please watch the 2 minute 50-second video on the asynchronous day, it'll give you a really nice review for what we went over today. So if you have questions, email me, but that is where we are today.